Hello, 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 hello. Okay, so, oops, okay again. Um, let's see, yesterday I did a lot after I went through the video. First I want to say I figured out what to do with the chunks, or like why I had chunks, why I had the soft links, and it wasn't exactly for the reason that I said. The reason that we have these soft links from key to the chunk of data with the objects inside is so that if we do update this chunk, what we can do is we can do a move operation to change one to the, or to move a new copy in replacing the old one, and that will be atomic. And so that's basically the way to do that without worrying that, while still having all the keys being able to point, without having to move them. Basically, the keys always point to where the keys point, and that works fine. And yeah, if an object does get deleted, basically we just go through all the keys of it and just delete them, and that also works fine, I think. And let's see. All right. Okay, I guess that does bring up a question, like if an object has multiple keys, then if there's multiple keys out there, then how do we delete them all at once? Basically we can't. Suppose that's true. So I don't know if that's a problem or not. Well, it shouldn't be, because the key's in memory. So as long as all the keys are in memory, and then we do the operations on the disk, and then we delete them out from memory, and then we're fine. We use STM for memory, everything's fine. The chunks, the reason that these have to be atomic and the keys don't is because of, well, actually they don't actually need atomic either. So I don't know. I guess the thing is that it's I don't know. Anyway, I'll have to think about that some more. So alright, that's chunks. So got a lot of stuff in here. So upgrades. So upgrades are just based on the key type. I don't know. Sorry, I'm going through my notes right now. So then we have like the DB system, which is going to be the thing that writes to this whole idea of the chunks and the soft links and so forth. One thing that became a big issue is calculation cascade. So the idea is that, alright, so you have like the root operation, which is, there's always a root object in the system, and that triggers off an action function which will run and probably create a bunch of other objects. And it really depends on how we process the objects, whether we have to reprocess them. So consider, let's say that we're compiling a bunch of files together to create an executable at the end of the operation. So in that case, we'll have a bunch of maybe file nodes here. We'll call these file nodes, and then below them, we might have symbols. So they create a bunch of symbols and so forth, each of them. And then below that, I don't know, some other thing like machine code or something, I don't know. And then finally, it'll link it all together into an executable, right? And that's the output. So the thing is, we don't, sorry, I shouldn't put that there. This is part of the action function, and this is a root node creating the files. we don't want to follow one path all the way to the executable, because as soon as we follow down another path, let's say this one, then if we already went and did the executable node, we have to rerun it for the next one, and then another one comes in, and we have to rerun it again, and so forth and so on. And that's not good, obviously. So to fix this, see, here's the thing, like, there's two ways to go about this, and I'm not sure what is the best way. One is to have like a sorted list in our input, and that sorted list will contain all the nodes. It will contain the ones that haven't been run yet, and that's based on their keys. And then there's also continuations. So like a node gets run by action function, and the action function might have, like some code to run on a CPU pool, and then something that switches to a disk I/O pool, and then maybe a network pool or whatever. I explained this before. This is just a simple cat thing. So at each of these spots, these get inserted into queues as well. The dogs outside are driving me crazy, but alright, so the point is that we would want to sort this whole thing based on the heuristics. So we want to say that, in the heuristics, what I mean is, like, if we look back up here, this node here, this exe node, this one reads from this guy and this guy and this guy and this guy. And so the nodes that can affect it become a large number. So this guy, is going to have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. But it's going to have like 12 nodes that if they change, this one's going to have to rerun, potentially. So that's what I mean by heuristics, is that each of these guys would have a number associated with them. And the ones with a lower number, like the root node, which has 0, obviously, because it never changes, they would run first. And that way we could help avoid this problem where we continually run. So that's one thing I was thinking of. The other thing I was thinking of, well, if I just have a straight FIFO queue, it might work as well, because we have the root node, and so it's like this, and like this, and like this. So this is a root node here. So if we have like the FIFO queue, we have a root, and then the root creates, this 1, 2, and 3. So 1, 2, and 3, and then 1 creates 4 and 5. I'm just going to label this. I'm not going to put in the queue yet. So the point is that by creating a FIFO queue where we process root first, and then we process 1, and 1 might create 4 and 5 here, and then we process 2, and then 2 might create 6, and then 3, and 3 creates 7. And this way, as you can see, we're not going to have the situation where we're going to follow like a path all the way down to whatever node, like maybe a special node that links everything up together to the exe, like in the scenario before. That won't happen. So I think it's possible that just a simple FIFO queue will handle a majority of the situations. Doing the heuristics thing, it just seems very complex, and I don't know. I don't want to do that for the first version. Maybe another version, but we'll see. I just want to see if it works or not. I don't want this to become, it's already dragged out pretty far, and I don't want it to become even bigger. So it's kind of just an experiment for me to play with Haskell and kind of learn how to do it. My next project is going to be a lot more fun. It's going to be a game based on Dwarf Fortress and OpenCL. Actually, probably CUDA, because I can't get OpenCL to work on my machine. And it's going to be like basically a whole 3D open world where each block has physics associated with it. And they all run on the graphics card together. So it'll be very interesting to see what happens with that. kind of want to be working on that right now, but I'm not. Instead, I'm working on this thing, and I just want to finish it up because I spent a lot of time on it. So, this is the idea. So we just create a straight FIFO cube. We process things in that order. We have a disk-based FIFO. So I looked on the web, and there's a couple libraries that can handle FIFOs. They're actually called DQ, which means they're double-ended queue, I guess is what the D&E stands for. And those can work as FIFO queues. And that will work for the memory portion of this thing, and then for the disk portion I plan to have like two files, and one file is going to be the front, and file is going to be the back, and the idea is we'll read from the back, and then we'll write to the front, and then when the back, we read all of the back, then we switch the front to the back, so now the front is now the back, and then we start writing into a new front. And that way, we can basically do a FIFO queue on the disk without having to worry about like if we did with one file, we'd have to worry about, like, oh, we read so far, and then we have this extra space here, maybe we'll write to it, but then what happens if we fill it up? Then we have to write to the end, and it becomes kind of like this thing where we just have pointers everywhere where we're going next. And I guess, I mean, that's one way to do it, I suppose. But then we have to worry about managing the free space, and that's a pain in the ass. So if we have two files like this, we don't have to worry about managing free space. And so basically what's going to happen is that we have a header record, which is just going to be an offset, and then we have the data is just going to be just the data, just neatly organized in rows for front and back. And then the only other operation besides this we need to do is we need to be able to commit the journal to disk. And so we do that, we just empty the memory queue into the front. So let's say this is the front, we empty it into there. And then we save both the front and the back, or you just move them to separate files. And I'm not going to really worry about if the back has like a gap here, it just has this offset here that gets set to a number that's not 0, and that will indicate where to start reading from. And so it'll be a little bit of waste of space, but who cares? So that's the disk-based FIFO, and that's as far as I got. I didn't really get a lot of time to work on it today, but we'll see about tomorrow. Talk to you later.